Alright, so we want to take this equation and we want to graph an ellipse. We know that it's an ellipse because we look at our squared values, our x squared and y squared, and the numbers in front are different. That means that when we get our equation equal to 1, we're going to divide by some number, and if I divide 9 by a number and 4 by that same number, I'm going to get two different denominators. So we're going to go through this and we're going to do our completing the square because we have x and y values in there. We have to get rid of them basically. We have to make them perfect squares. So we're going to combine my x and we're going to, well, let's just do one step at a time. So we're going to say 9x squared minus 18x, and then we're going to combine the y squareds with the y's, and we're going to move the constants to the other side. Then, instead of completing the square like we're used to with just it being 1x squared, we have to factor out that 9 and we have to factor out that 4. So we can factor the 9 out of just the x values. So x squared minus 2x. Now I'm going to do plus blank like we're used to for completing the square. I'm going to factor 4 out of the y value. So we're allowed to do different values. Plus 4y plus blank equals 11. Oops, I'm sorry. 11 plus 2 blanks. And that just reminds me, I do that when I'm completing the square, so I remember to put my values over here. Now we are going to take half of b, so half of b is negative 1. We're going to square it, which is 1, and we're going to add it to both sides. Then we're going to, oh, I just messed that up. Let's back up. So typically, what we're used to doing is adding 1 to both sides. What I forgot is that there is a 9 out in front of here. So it is not just 1 that I'm adding, I'm actually adding 9 times 1. So I have to actually add 9 over to that side, just so that they stay balanced. Then here we're going to take half of b, which is going to be positive 2. Positive 2 squared is 4, but I'm actually adding 4 times 4, so I'm really going to add 16 over here. So now we're going to go through the same process that we are used to with completing the square. Get a different color. We're going to drop down my 9, and remember it always factors itself, so half of b was negative 1, and then we have 4, and then half of b here was 2, and then that's going to give me 36 when I add those together. It's an ellipse. Well, we have to get it equal to 1, so we divide. Let's just go ahead and divide everything by 36. That means 9 over 36 simplifies to 1 over 4, which was nice. And then 4 over 36 simplifies to 1 over 9. So that right there becomes my equation. Now that is much more manageable to graph than what it looked like initially, and it wasn't a whole lot of extra work. So now we're going to sketch it. Center is at 1, negative 2. So if I need to write that out, I can go ahead and do that. Vertices, covertices, and foci are then what we're looking for. 4 is under my x, so I'm going to move left and right 2 units, which is the square root of 4. And those are this time going to be covertices because those 4 is smaller than 9. That tells me I'm going to move vertically 3 units to get my vertices. So 1, 2, 3, and that's my ellipse. We have a vertex at 1, 1, and at 1, 2, 3, 4, 5, negative 5. And then we have a covertice at negative 1, negative 2, and at 3, negative 2. And you can always double check, make sure the distance between those is that number. So the minor axis does have a length of 4. My foci then, a squared minus b squared is c squared. A is 9, b is 4, so c equals radical 5. And remember, we move in the direction of the vertex. So radical 5 is just over, what is that, just over 2. 1, 2, there's a focus. 1, 2, and there's a focus. So this time, we say, okay, my x value is 1 for both of these points. We went over 1. We always start at the center, which was at negative 2. We went up and down radical 5 units to get to those foci.